Hey everyone, this is Sebas from Nextmove, and today I'm going to be showing you our apps from models experience using the Gurobi solver. So for today's agenda, we're going to first create a decision model that solves a simple knapsack problem. Then we make sure that it works by running it locally to then push it to a Nextmove cloud application and finally run it again, but this time remotely. And this is a notebook's first experience. That's why we're here in a Jupyter Notebook. So let's dive right in. First, let's install our necessary Python packages. Of course, we're going to be needing Gurobi, and we're going to be needing Nextmove. However, for this apps for models experience, we need some additional dependencies that we're going to specify using the all keyword. Now that everything is already installed, we're going to add all our necessary imports, which I have them ready beforehand. More importantly, we're going to be using Gurobi and Nextmove. Cool. So let's start with our decision model. A decision model is any class that implements the Nextmove.model class or that inherits from that class. So I'm going to name my model just decision model, pretty obvious, and it inherits from Nextmove.model. All right. This class, Nextmove.model, implements a solve method that we need to actually implement ourselves. So it takes in an input of type Nextmove input, and it produces a Nextmove output. Inside of the solve method is where we're going to place all the main logic for solving our decision model. So to do that, we can reference our community apps, and we can look for the Python Gurobi knapsack app. And in here, there's main.py, where we conveniently already have the implementation of a decision model. So we can just copy that code. And we can see here that status is not defined. So let's go back. And we are also going to borrow this, which is the status before or after optimizing. Cool. So my custom decision model, we will create a Gurobi model, add some environment variables to it, add a constraint, set the objective function, optimize, and then choose the relevant items for my knapsack to then finally construct a Nextmove output. And it's time to run this model locally so that we can actually check that it works. The first step is to define the options that the model needs. So let's again go back to our community app, and we can borrow these options from here. Let me fix indentation. All right. So because we're working in a Jupyter Notebook, we don't really need input and output as we're not working with a terminal. So we are simply left with the duration that we use to limit our solver. And now we're going to instantiate the model. So we can simply define a model variable, which is an instance of my decision model defined above. And then lastly, define some sample input data. So I can define a sample input, and going back to my community app, there's an input.json with an example of my knapsack problem. I have several items that I wish to maximize the value for by respecting a weight capacity. So before running the model locally, Gurobi does require a license as it is a paid solver. So to be able to write that file in the file system, we're going to use this magic write file command that comes with Jupyter Notebooks. And we're going to create a gurobi.lic or license file with these three variables. For privacy, I will now go ahead and replace these variables, execute the cell, and then go back to leaving them as replace me. So I'm going to be doing that right now. So I already have my gurobi.license file locally. And now I'm going to actually use my decision model. So first, I create my Nextmove input, which takes in some data. It is my sample input, and it takes in some options. Now, the output that I can obtain is simply calling model.solve, and it takes in my input, as we saw from the signature above. And once I have my output, I can do something short, like print it, In this case, it should be, for example, the output.solution. And let's run that right now, making sure that I'm not going to be showing you any of my license information. Cool. So this ran locally, and I'm just hiding here some license information, so I'm not showing the full output. But now that we know that our model runs locally, it's time to push it to the cloud. So to push this model to the cloud, we first need a client, which is a cloud client that allows us to communicate with the Nextmove cloud. And I already have my API key configured as an environment variable. Now I go ahead and define my cloud application, which takes in a client, and it is identified by an app ID. If you already have an application, you can simply put your ID here. If not, you can, for example, go to the Nextmove Cloud Console and add a new application, create it. You can also do this with the Nextmove CLI. In my case, I already have an application ready named apps from Models Gurobi. So I'm going to paste this here. So for Cloud to know what to do with this custom Python model, I'm going to be needing a model configuration. This model configuration needs a name for my model. I can just call it, for example, Gurobi model. I'm going to specify the requirements that my model needs. And requirements act as a requirements.txt file. So each item is like a line in that file. So I know that I need Gurobi Pi. I also know that I need Nextmove. Let me just check the versions for those. So Gurobi Pi, it's 12.0, and Nextmove is 0.14.1. So it's 12.0 and 0.14.1. Cool. And from that model configuration, I can create an app manifest. And an app manifest instructs Cloud on how to run an application of any kind. And there's a convenience function called from model configuration. So I can simply create the app manifest from this model configuration. One important part that I need from this manifest are the files. So by default, I'm going to be appending some files that are relevant to my model. But in the case of Gurobi, I know that I need my Gurobi.lic or license file. So I'm going to be simply be doing manifest.files, and I'm going to append my Gurobi license file to it. And now that my manifest is ready, I can push my model to my application. So I need my model. I need my model configuration. Whoop, I don't need all of these. I need my manifest as well. And lastly, I'm going to go ahead and tell it to enable verbose mode so that I know what's going on. So what this will do is it will encode the Python model, bundle Python dependencies, and then push all of that to the cloud application. And I'm going to be fast forwarding to when this push process is finished. Cool. So our push process is finished, and I can check that in my application, I have that latest pushed executable. So it's time to run the model remotely. And to run the model remotely, I can actually run my application. And I'm going to create a new run with result, which will start a new run and pull for results for me. The input is going to be my sample input that works, and it also needs an instance ID. Every Nextmove cloud application, any custom application, comes with a default Devin instance, so I can just use that. And an instance is like the endpoint for your application. And once I obtain my result, I can sure print, but in this case, it's going to be the output of my result. So let me execute this, make sure that it runs. All right, so we were able to obtain a result from the remote application run. And in the process, I actually had to repush again So I realized that I didn't pass in the options in my model configuration. So make sure you do that. And I can check in my run stable that we have the run that succeeded. So we can check the input, the result, details in general, logs if we have them. So this is our abstract models experience working with custom decision models directly in Jupyter Notebooks. Thank you so much. Until the next one.